I just created this message overlay class, and I posted the code here on my wiki. And here it is, class message overlay. The purpose of this is it gives an easy way to display messages on the user interface or in a game, in an XNA game. And what I'm going to do is explain about how to use this class. So for that purpose, I'm going to create a new XNA project and show how to use this this class. So I'm going to start up Visual Studio and go ahead and get started on this. So let's see, we'll do a new project, and we'll give the solution will be, say, Windows Game 1 is fine, and the name will be I call it message overlay. Message overlay example. Alright, this is good enough anyway, so let me go ahead and create that. It's Windows Game 4.0. And so let's just check, see if this builds. This should, of course, build. And we run it, we get a blank screen. There's the blank screen. Okay, so now what we'll do is we'll create this class called message overlay. It's a C# class. Pop it right in there. And here is the code. Just going to grab this. And I'll drop it right in there. I'll fix that name in a second there. This should be message overlay example. Message overlay example. That's the namespace that matches the namespace here in Game 1. It's taken from the name of the from the project. And as you can see, I've got my comment here. Class provides a means to display multiple messages to the user, and I'll illustrate that in a second. And there's some description about how to use this, which I won't read because I can explain it. So in this class, this is a static class. That means it has only static variables and static functions. And inside the static class is a non-static class called message. This is a private inner class, so only functions inside this message overlay class has access to the message class. And the message is just this message class I created just as a way to associate some message text with a value, seconds to live. So when you display a message, you want it to be removed after so many seconds. So this is the pair of values that are needed to manage that type of a messaging system. Here's the constructor. It takes the text, which is a string, and seconds to live, which is a double. These are the setter methods, getter and setter methods, property values. This ends the inner message class. Now we have the as you can see, these are the constants. So this can be adjusted according to how you want these messages to appear. This is the messages will start in some point, and that as messages need to be rendered, they will be displayed under the previous messages. So this would be the start X position, 100 pixels, to start Y position, That's 50 pixels. And this is the default seconds to live. So if the user code doesn't specify the seconds to live for any particular message that needs to get displayed, then 5 seconds will be used. Here's the sprite batch, sprite font variables or references, and these will be passed in to the message overlay class during initialization, which is done right here. As you can see, the init method takes these sprite batch and sprite font values. And here's some way of managing the messages. We have a message list. This is the messages that need to be displayed. So we have a list of messages. Each have their seconds to live variable that's being decremented as they're being rendered through in the game loop, and that seconds to live gets decreased until it reaches 0 or less than 0, and then it's removed from the message list. Now, rather than garbage collecting these messages that are removed from the message list, what we do is we put them on to the reusable message list. And the reason for this is that we want to minimize the amount of work that the garbage collector does. This is important on an Xbox 360 game, and it may be important on Windows Phone 7, or what is it called, Windows Phone. It might be important for the Windows Phone as well, but I haven't tested that actually. But I know that's an issue with Xbox 360. Is the garbage collection system is not as good as the garbage collection on Windows, and if you need to if you're generating too many objects and destroying them in the game loop, then it's going to cause interruptions in the gameplay. So we don't want any objects being garbage collected from this class, from the activities of this class. So here, this is line position. This is a vector. This is used internally in the draw method rather, to determine where to render the message string. Once again, this didn't need to be declared here as a static member variable, but we did so because we didn't want this vector to be garbage collected in the game loop. So here's the init method. Now we test. It's possible to call this init method too early, so we just want to make sure that the sprite batch and sprite font values that are getting passed in are not null. So we check that with an assertion here. Then we save those references. And finally, here's an add message. When the user code wants to render a message, they call add message. This is a static method. They call add message. They pass in the text. They optionally pass in the seconds to live. If they don't specify that, then it gets set to the default seconds to live. So what do we do inside add message? Well, we declare this message reference, and we want to check the reusable message list. If the count of items in the reusable message list is greater than 0, it means we have a message that we can reuse. So rather than creating a new one, we go ahead and pull that one off. So we'll take it from the front of the list. So at position 0, we pull off the first. This is a reference. We copy the reference. It's a pointer. These are all pointers. This is a pointer to an instance of message. And we take the pointer, we store it into this message variable, and then we remove the pointer from the list here. Now, this may actually result in some hidden garbage collection. That's something that I'm wondering about. So the way to avoid that would be to create a fixed array of messages or message references, and to manage that array. So that's something that we could do. All right. So, but I wonder about that. I'll have to sort of research that. Maybe this because what internally we don't know how they're managing this list. It could be when we perform a remove that that some like link class, some kind of internal class, some internal object gets garbage collected. So I'm wondering about that. Anyway, once we get this message object removed from the reusable list, we set that message's text property and seconds to live to the ones being passed into the function. Now, if the reusable message list has 0 items on it, then we call the constructor for the message class, and we get that. In either case, we add this message reference onto the message list. So this is how that add message function works. Now, draw, as all methods in this class, it's static, and this will be called from somewhere. And but it must be called in a regular way. It must be called in the game loop. And so what we do there is, of course, if there's nothing in the message list, which is normal, this would be the typical scenario that the message list is empty, then we'll just return. So rather than spending any time doing anything else, let's just get out of here. That'll be the typical situation. So we're cutting down on a little bit of overhead by checking that early. So getting ready, if we reach this point in execution, it means we have some messages to render. So we call begin on the sprite batch. That's the procedure for rendering text. We iterate through the message list. We use the for each construct here. And for each message in the message list, we call drawString on the sprite batch. We pull the text out of the message here and draw it at the line position. And here is a color value here. I think I might change this actually. This should be something like a color, and make this a constant. I'm going to change that. So this is the color. Let's make that a constant. Put that up here with the other constants. So we're trying to put all in one place, all of the parameters that you can alter in order to change the way this class works. All right, so we got that to work, and so what we do here is, we're in this draw method. The game time is being passed in here, so we're going to make use of that right inside the draw method rather than having a separate update method. We're going to do this, and so we take the message, the seconds to live on the message after we draw it, and we're going to decrement. We're going to decrease, rather, not decrement. We're going to decrease this seconds to live variable in the message class by the total number of seconds that have elapsed since the last time the draw method was called. And and then we're going to increment the y position of the line position, the y value of the line position. We're going to we're going to add to it, increase it by an amount that's equal to the line spacing for the font that we're using. So that's the font here that we're using to draw the string. Now this for each iterates through all the messages that need to get rendered, and then after we do that, of course, in that loop we are decrementing this seconds to live value here. So after we do that, we're going to have to pull out those dead messages. So we're going to go backwards, and we're going to start with the index equal to the number of messages in the list minus 1. That gives us the index of the last element. We're going to continue while the index is positive or non-negative. We're going to decrement the index here. Whoops, keep doing that. And so as you can see here, we take care of that. We pull the message out here, the ith message. We check its seconds to live property, If it's less than or equal to 0, we're going to put it onto the reusable message list by calling add on the reusable message list, and we're going to remove it from the message list, the active message list, I suppose you could call that. And when we're done this whole process, we need to reset the Y value of the line position, and of course end the sprite batch routine. That's it. So let's see how that works. This is how you would do it. Inside, this is your default game class. Game1 extends game. And let's find a good place to initialize this. Here it is. We've got the sprite batch. We get the sprite batch here, but what we're going to need actually is a sprite font. And we'll need to create that. And I can't remember how to do that. I'll need to think about that. Okay. We need to access the content manager, and we're going to load a sprite font. And we pass in the name of the font here. And I'm going to call this Arial 14. Now we need to create this this named sprite font in the content project. So before we do that, though, let's continue on here. So we create that sprite font, and then we will initialize the message overlay. You can see it wants the sprite batch reference, and it wants a reference to the sprite font. There we go. That handles that. You can just tighten this up a little bit. And here's update. We don't need that, but here's draw. Draw is necessary. And what we'll do there is call the draw method of message overlay. Pass in the game time. There we go. And we should actually delay this and do this after we draw like the scene objects and the other GUI components, so that the messages are overlay all the other visual elements in the screen. Now, one thing we are going to do is need a way to render the message. So what I'm going to do is sort of copy this this code here. Let's take a look at this. I'll use the keyboard. So I'll do this. I'll do if the keyboard. Let's see if it get state. That's a method, not a property. And this is get pressed keys. This is, let's look at is key down. We'll try that. Is key down, and that'll be, oops, key dot say, alright, the A key. If the A key is down, then let's say so with the message overlay. So here we're going to add a message, and we're going to say A key is down. And I think we can do the same thing with. Of course, this is very wasteful. So let's do this. Let's see, it's get state. So this is a little too wasteful. So let's go ahead and clean that. This is the keyboard state, say. So I'm going to call it the keyboard state. And let's go ahead and grab that from here. So this is a struct, so we're actually making a copy. This is not a reference. This is, you can see that's a struct. So we're copying the entire value of the struct here. And once we have the keyboard state, we're going to check to see if the A key is down. And let's go ahead and have an else if here and check to see if say if the B key is down, just to get some variety. And then we'll add the message B key is down. We're going to need to create a font for this to work, so I'm going to go ahead and do that inside this message overlay example content. So let's add a is it new item? Here it is, a sprite font. This is the name down here. I'm going to call it Arial 14. That gets inserted in there. Let's open that up. And this is the font name here. This will be Arial 14. Sorry, it's Arial. Font name is Arial. The size is 14. That's already set for us. Alright, so we have it. This name here, Arial 14 dot sprite font. This the Arial 14 must match this string right there. Let's see if it builds. It failed. Let's fix it. What's going on here? This is a constant, private constant color. This cannot be declared a constant. Is that because it's a struct? Color cannot declare instance members in a static class. This is an instance member. This is private. Alright, we'll leave that alone then. Not sure exactly what's going on there. Oh, so this would be private static color, like that. I'll have to think about that one. And let's press A. Actually, I have to do it quickly because it's not a full key press. You know, this is A, B, like that. So anyway, it illustrates the thing. And you can see the messages scroll off the bottom there. I have to press pretty quickly just to get one on there. Alright, handling the key presses, that's another issue. And in fact, I'm going to provide some code for that in a moment. So that's the basics of this class. What I tried to do is keep it compact and not encroach on the rest of the program. As you can see, it's pretty self-contained. You have to call this init method, and it has this external dependency, these external dependencies here, and after that it's pretty self-contained. Alright, that's it.